Okay, this is kind of where we ended up talking about soap and how soap works. It's an emulsifier. These are kind of called micelles. Let me see if I have an eraser here. So yeah, I mean milk. Milk is an emulsion. Okay, folks? Milk is an emulsion, and so milk naturally has some surfactants or emulsifying molecules that can emulsify fat in water. So milk is what, 4% fat? Whole milk is about 4% fat. And you got this emulsion of fat in water, that's milk. And so the fat is not soluble in the water, it's been emulsified. That's why you can't see through milk, because of the particles that are floating around in there, these little things like that. Okay, I want you to appreciate what a phosphate ester is. A phosphate ester. We've been talking about esters, and esters are kind of like this. Okay, the phosphate ester is kind of like this. Only the phosphate has 4 oxygens around it. But you can kind of see this structure in there. So they're talking about a phosphate ester. And you can get that from reacting an alcohol with phosphoric acid. And you see you take out that water right there, and you get this RO phosphorus bond right here. RO phosphorus bond, phosphate ester. These are very, very important in biochemistry. The DNA backbone is a sugar phosphate backbone, and it's phosphate esters. Phosphate ester bonds going up through the DNA backbone. ATP is a phosphate ester, adenosine triphosphate, adenosine diphosphate. Yeah, so you're talking about it right here. ATP, ADP, they're kind of, I think I got them on the next slide. Here is your phosphate ester right here. This is adenosine triphosphate. This is the energy molecule in the body. But the phosphate here has another phosphate group attached to it and another phosphate group attached to it. 3 of them in a row. That's ATP, adenosine triphosphate. This portion, if you just kind of, that right there is a nucleotide. That would be the adenosine nucleotide that would be used to build up DNA, in this case RNA. You can tell it's RNA because there's an OH right here, I think. That'd be, at any rate, that is part of DNA, that base. This is what's floating around. The mitochondria make this. When your body needs energy, it breaks one of these bonds right here, and that releases a lot of energy. That's a high energy bond right there. You break that bond and it releases a lot of energy, and it becomes ADP. So when ATP gets converted into ADP, it releases a lot of energy. And your mitochondria is where it takes ADP and converts it back into ATP for when you need energy. Okay, so an athlete, someone that's in pretty good shape, has a pretty good system of, and a pretty high level of ATP because they need a lot of energy. And that's where they're getting it from. You and I need a lot of energy, and this is where we get it from. Body converting ADP into ATP. But the point here is that these molecules have in them phosphate esters, phosphate ester bonds. So just be kind of familiar with the structure of a phosphate ester. You've got a CO, phosphorus with a double bond to an oxygen, but that phosphorus actually has 4 oxygens around it. The phosphoric acid is H2PO4. This is phosphoric acid. Wait, what is it? It's H3. I'm sorry. It's H3PO4. From 1305, you should recall the PO4 ion is the phosphate. So H3PO4 is phosphoric acid. React that with an alcohol, you get a phosphate ester. Yeah, here's showing the ATP breaking down into ADP, adenosine diphosphate. So nothing changes over here. We've just clipped off a phosphate group and is releasing 32 kilojoules of energy per mole of those molecules being converted. That's a lot of energy. That's actually yielding a lot of energy right there. ATP going to ADP. Okay, that pretty much finishes chapter 14. The last 2 slides are summarizing some of the reactions. So you oxidize an aldehyde, you get a carboxylic acid. You oxidize primary alcohol, you can get a carboxylic acid. All right, here's esterification, which is a carboxylic acid plus an alcohol. Here's neutralization, it's a carboxylic acid plus a base. It's an acid plus a base. Dissociation. It's just dissociating in the water the carboxylate ion and the hydrogen ion. There's a summary in words of the various different reactions. I think they are all depicted right here. Let's take a look. There's a couple of these I'll cross out. Not a whole lot, but let's take a look at it. At the top, primary alcohol forms an aldehyde, can all go on to form a carboxylic acid. Carboxylic acid can dissociate. Carboxylic acid can react with a base to form the salt and water. Esterification. Carboxylic acid plus an alcohol forms an ester plus water. The hydrolysis of an ester in an acidic environment, ester plus water forms a carboxylic acid plus an alcohol. Kind of glad these are right on top of each other because you can see this is the reverse of that. We've done all those reactions. Saponification. All right, let's fix this. So ester plus sodium hydroxide yields the salt, the sodium salt of the carboxylic acid and the alcohol. All right, I didn't really go into this reaction. You can form acid chlorides. You can convert carboxylic acids to acid chlorides. you can react the acid chloride with the carboxylic acid and form an anhydride. You can see the anhydride. You got a carbon-oxygen double bond, oxygen, carbon-oxygen double bond, right in a row. That's acid that's an anhydride. But that's not a reaction I'll hold you to. Here, basically recognize. Oh, I'm sorry. I put the box around the wrong thing. Basically recognize, I expect you to recognize and appreciate what a phosphate ester is.
How would you ask us in a follow-up question? Would it be a multiple choice or would it be to draw it out?
I don't know. Probably it might be giving you a drawing. Say, it might be A, B, C, D. Which of the following of these is a phosphate ester? Yeah. Yeah, I don't know what else might ask there. Might be what type of ester is found in ATP or something like that. Yeah, just and we'll come back to this in chapter 20 when we look at DNA and RNA. We'll point that out again. So that's it. There's a lot of critical reactions right here in chapter 14. Any questions? I'm gonna move on now to the last organic class is where we deal with nitrogen. All right, ready for chapter 15?